Fire pupils, here's our next and final video on recurrence relations, and this is generating a recurrence relation from using 3 consecutive terms. Okay, so i.e. you're finding the A and B value of your linear sequence. Okay, it is very, very significant that the question will give you 3 consecutive terms, because from a recurrence relation we talk about the next term in the sequence is the previous term. Okay, so there has to be a connection of consecutive terms to allow that. Okay, this is a type of question that's best shown by example. So looking in here, recurrence relation is defined by just a typical linear recurrence relation, and we've got 3 consecutive terms. We've got U1, U2 and U3. Okay, it's not got U0, that's not important. As long as we've got 3 consecutive terms, they could equally have given us U20, U21 and U22. As long as there's 3 consecutive terms, you're able to work out your values. Okay, and what you're looking to do is using your knowledge of a basic recurrence relation to be able to form 2 equations. Okay, so if we look here, we know that our recurrence relation is in our linear form, and we know that U1 is equal to 5, or our first term out of our 3. Our next term out of our 3 would be A, whatever A would be, lots of the previous term, which is A1, plus B. Okay, therefore U2 we know is 9.5. U1 we know is 5. Plus B. Okay. And I'm going to rewrite that ever so slightly as 9.5 is equal to 5A plus B. Okay, back to my sequence. My third term is A lots of the one before that, so U2 plus B. Therefore, I now know what U3 is, which is 20.75, and that's equal to A times by U2 which is 9.5 plus B. So again, just using our recurrence relation, and that allows me to write my recurrence relation as 20.75 is equal to 9.5 A plus B. Okay, the 9.5 being the middle term, that appears twice within my 2 equations, but what I've got is the situation of 2 linear equations with 2 unknowns, and the same as you would have done any other time, you're looking to solve simultaneously. So simultaneous equations will get you an A value and get you a B value. Okay, so go through the process. My simultaneous equations, I would normally write 5A, so first term plus or minus the second term is equal to our value, and 9.5A plus B is equal to our value. And what you often get here is the ability to be able to, what you always get here is the ability to be able to eliminate our b value. So I'm going to call that number 1, I'm going to call that number 2, and multiply that by -1, we'll get you a positive and a negative. So -5/8 minus b is equal to -9.5, and 9.58 plus b is equal to 20.75. In a simultaneous equation, that's the situation that I want. I want to be able to eliminate my b's, and I do that by adding my two equations. Adding 3 and 4. So 9.58 minus 5a, or minus 5a plus 9.5a, however you wish to read it, is 4.5a. The b is eliminated, and 11.25 when we add those together or subtract the 9.5 off. Divide both sides by 4.5, I get an a value of 2.5. So sub a equals 2.5 into, always going to be 1 or 2, that's the simpler equations, so I'm going to put that into 1. So 5 times 2.5 plus b is equal to 9.5. 10.5 plus b is equal to 9.5. Take away 12.5 from both sides, I get a b value of -3. So that's a value found, that's b value found. The question is, find the values of a and b. We've got it. However, if we're looking at our recurrence relation, the next term is equal to 2.5 lots of the previous term, subtract 3. And that there is the recurrence relation for these 3 consecutive terms. Okay, so we're looking to use each of the terms, form 2 equations, and then solve simultaneously. Please refer to the PowerPoint for questions. Okay, and that is the end of our recurrence relations.